Assalamu alaikum wa rahmatullahi wa barakatuh. Today we will cover Unit 10 of the course M256 Software Development with Java. The unit is titled Coding and Testing. In Unit 9 we learned about kinds of detailed design decisions, and we show you creating of a utility class with all its details and how we made this class a class to be reused in the future and part of some software component-based development. We learned about composition and inheritance and to decide how to use and when to use either one. In this unit, we will learn of how to test our classes that we have built and our overall implementation model, of course after performing the implementation itself. So we'll have an overview of testing, describing the purpose of testing and the different forms that it may take. We'll have a look about how to start implementing a system based on the implementation model that we have completed in Chapter 9 or Unit 9. We'll explain how to specify our test cases based on the method specifications and how to write corresponding tests. We will also give a practice in coding and testing methods required for a use case. And we will examine implementing the hospital core system. First, we need to know that testing can be partitioned into two categories, either verification or validation. Verification is trying to answer the question, has the product been built right? Which involves checking that all aspects of the system and its documentation are consistent and complete with respect to each other. On the other hand, validation is trying to answer the question, has the right product been built? This will involve checking that all aspects of the system and its project's documentation are consistent, but this time with the customer's requirements. In Unit 2, we have covered what we call acceptance testing, which we use to check that the system is consistent with the customer requirements. We build test cases, and all this will try to find out whether we have the right product being built, and that's a validation work. When we do testing, either in case of validation or verification, we are not only testing the system itself, we are testing the documentation of the system also. So we will test the conceptual model, the initial model, the implementation model. We will concentrate on tests that can be applied to the core of the system. Test will also check that specific aspects of the code is consistent with the implementation model and ensure that it correctly represents the design that we have completed in the previous units. We don't just check that the code does what is what it is supposed to do. We also need to have a look and test a feature that often overlooked, which is be sure that the code does not do anything extra, because doing extra things is as bad as doing less things. With testing, we should be able to uncover any defects or bugs that's available in the system. We may not be able to uncover all defects, but the dangerous ones should be covered. The important ones should be covered, but we know that we cannot reach 100% free or bugs-free software. So at one point, we have to stop testing and accept that there are some bugs that we can live with. If we need to define a test case, we need to specify two main things. We need to specify the data that will be used during the test, and that we call the fixture. We also need to expect results of the test. So we need to know what are the expected results of the test. So if we get the same results, then we know that our test is successful. If we get a different results, then we know that we have failed in the test and there are some bugs to be fixed. One approach for coding and testing is called test-driven development. In this approach, tests are written based on specification of the aspect of the system under test, and that will be done before the code is written. In this development approach, first, test cases are specified based on the specification set out in the implementation model, and then tests based on the test cases are written. After writing these tests, the code is written. So the test cases are built and written before the coding. When we code, then the test is run, or the tests are run. If the result doesn't meet the expectations, then we know that a bug has been uncovered and that bug needs to be fixed. In this way, code is developed in small increments. So each time we build a piece of code and we check it or cross-check it against our test cases to be sure that it doesn't include any bugs. Then the same thing will be repeated. Code test cycles will continue until we complete our coding and testing phase. Test-driven development has some benefits that you need to remember. This approach helps identifying where problems are occurring so that they can be solved as they arise. It creates confidence in the system because it's built step by step, and we don't move to the next step only if we are sure that the previous steps are all correct and has no serious bugs. In general, this development approach, test-driven development approach, found to lead to a lower incidence of bugs in the operational system. In this unit, we will use a simple testing strategy called Blackbox Testing, where each method is tested against its specification in the implementation model, without examining the detailed code. If the detailed code is examined, then we call this testing white box testing. But in our case, we are only using a method that will check the method of testing that will check methods specifications is matching the method implementation. And when we are doing this, we are doing a verification testing. Now in this case, or this method of testing, or I may call it strategy of testing, I mean black box testing, it's a kind of standard practice that we test around the boundaries. What do we mean about the boundaries? For example, if we take a collection, then we say whether the collection is empty, means it has no elements in it, or the collection is full. Being empty is the lower boundary of the collection, and being full is the upper boundary of the collection. If I am testing some value, say integer value, I will test around the 0, a very big negative number, a very big positive number. So I go to the lower boundaries and higher boundaries. Now we come to testing the code, and in testing codes we have some common phases to be implemented. We have the unit testing, then followed by integration testing and possible regression testing, and then system testing at the end. Let's take them one by one. Unit testing is the testing of individual units of software in the system. This individual unit can be a class or can be a method. To be able to test a class, we need to create an object of that class and then perform all the behaviors of the class using that object and see whether we are getting the right results that we are expecting. In Java unit provides for us a method or a way for unit testing. After performing unit testing, and when we are sure that one unit is totally fine with testing, has no problem with it, no bugs in it, and another unit is also ready, we need to combine both units to have a bigger unit or possibly a subsystem. So we need to integrate the units to have bigger units and possibly subsystems. This integration needs to be tested also to be sure that when integrating two units we don't have a problem because of this integration. When we integrate two subsystems, we want to be sure that we don't have problem because of this integration. So basically, integration testing is usually defined as checking that problems do not arise from interacting of systems components. One approach that we may use when we do testing is based on use case driven approach of implementation, where we concentrate in coding and testing methods involved in one use case. And since these methods can be used in different use cases, then in a way or another we are tackling another use case and we are having more components added to our system under testing. Now changing in the system or adding more aspects of the system can sometimes damage or change the results of previously checked components. So although we have checked all the components previously, but if we change or add more components, then this may affect the results of testing parts or components that were running correctly before. That's why we need to do the regression testing to ensure that no damage or change has been made to previously working aspects. Regression testing is vital not only while the system is being created, but when the system is operational, because we continue changing on the code, and we want to be sure that the changing in the code in one part of the system doesn't affect the other parts of the system. It's good news to know that Java Unit facilitates regression testing also. Now, when the system is complete, we go through what we call a system testing phase. In this phase, we will test the overall system, and when we do test the overall system, we don't really consider functionalities anymore now at this level, because we have considered all that in the unit testing, the integration testing, and the regression testing. System testing will involve aspects that are related to quality in the system, such as performance, security, and other quality aspects of the system. If you wish to consider the hospital system components, then we can think of each class as being a small component in the system, and these systems are all in a bigger package, for example, called hospital core, including all the core objects in the system. And package, as you know, represents the component-based development in Java language. Now we will cover of how you may start implementing your implementation model and see what do we may implement in our first code iteration, which is actually the first stage in implementing a core system. That implementation will focus on the basic structure of each class, its attributes, link references of that class, constructors of that class, and attribute getters, methods, and also toString methods. If you notice, we find that setters methods are not part of this phase. So the first iteration of development, the first iteration of coding doesn't include the setter methods. It includes the attributes, the references, constructors, attributes getters, and toString method in that particular class. We start by the attributes, and we know that the attributes basically can be implemented by using instance variables. So we declare instance variables that we designed in the previous phases to represent the attributes of a class. These attributes can be of primitive data types like integer, double, and it can be of reference data types like, for example, string or patient maybe. If you have a look at this description of the class patient, you have the attributes person, which is itself a class. We have links that reference word and team. We have collections that reference collection of objects like doctors and so on. So now if you want to implement these instance variables first, we start with the instance variables. You find that we define the attribute person as a private object of type person, and we implement the references word and team as private also objects of type team and word. We define the collection of doctors as private instance of the interface collection. After declaring the attributes, we build constructors for our classes, and in our case, we need to build a constructor, at least one constructor, for class patient. This constructor will basically initialize the main attributes in the class patients. It will initialize the attribute name, sex, and date. The precondition of this constructor, just like any other constructor, it will create and initialize and create a new object of the type, and in this case it will create a new object of type patient. And the object must be assigned to the newly created patient's object person instance variable. Of course, you can add more constructors to your system based on object-oriented paradigm. We can have more than one constructor in the system, and you can decide what attributes you need to initialize at the time of creating your object. Here are an example of constructors. As you can see, the constructor patient is having parameters name, sex, and date, where within the constructor you have objects created of type person and type doctors, which is a hash set object. So the constructor may take parameters, but within the constructor you may define objects, which normally is defined as attributes of that class. Same goes for the word. We have some attributes: a name of type string, sex of type sex, and a capacity of type integer. Beside all these, we have another object defined within the constructor of the word, which is an object of type hash set for storing the collection of patients. Now, after implementing the attributes and the constructors, we need in the first iteration to implement the getter methods. These methods returns information about the values of the attributes. For example, name of the patient, name of the word, and all other attributes in the class. So for every and each attribute in the class, you may need at this iteration to define getter method for that attribute. It's quite easy to build getter methods, and in most of the cases the IDEs will provide you with the implementation of these methods, because it's just return the value of the attribute. Getter methods are very important for testing, because at any time I need to test my code and my class, and I use the getter methods to get the state and the states possibly of my object. So they are very important with testing the system and the classes. Here are examples of getters method. For example, get name of one class, possibly can be a word or a person or a patient, and it just returns for you the name of that object. And of course, you have a return data type, which is the same type of that attribute in the class. Very commonly used comments format is the one we are using here, and these are a format that can be used to generate description of the code. So these kind of commands, you find them in Java doc interface and facility, to allow you using the commands within the class to create a description and a documentation actually of your class, and that will be very important for future users of your class. So if they want to use your class, they will refer to this documentation to know how to use the class, what constructors are in this class, how to call the methods of the class, and all the other details that a normal programmer will need. The same way goes for other getters methods in the classes of the hospital system. They are the same way. In the same way, they are returning some values of the attributes within the object. More of getter methods in the hospital system are shown in this slide and also in this slides. In chapter 9, we have covered the enumerated types, and we said that this is a very important and useful type when you have a limited number of values for one type, like for example the grade in case of a consultant doctor or junior doctors. They have some particular grades, only 1, 2, or 3, and this type can be defined as enumerated grade type, implementing the interface serializable. This is very important to know, and you as a software engineer and software programmer should be always able to create your enumerated types, especially for cases like sex and grade in this case, and weekdays and so on. So you should be able, and also in your tests you may be asked to create some particular enumerated data type. Here is the implementation of the sex as being enumerating data type, implementing again the Java serializable interface. As you may remember, we mentioned earlier that the implementation model of a system is used as a blueprint in implementing the methods required for a particular use case. Here we will continue using the test-driven approach along with the use case-driven approach of development. So we are using use case-driven approach development along with test-driven approach of development. Then we will, in this case, have to implement use cases one by one, and for each method of a use case, we test it using our test cases and declared and made clear in the test-driven approach. So we will take a use case, we will build test cases for any of the methods in that use case, and we code the method and test it immediately. This approach is quite appropriate in our situation, since for each use case the implementation model includes dynamic models, and these dynamic models show how the methods involved in the use case fit together. So in this case we'll go through the use cases one by one, take the method in the use case one by one, code it and test it according to the test-driven approach. As you know, in the dynamic models, each use case, the design phase resulted in one or more dynamic models. Why we may have more than one dynamic model? Because we have different situations and different specifications. For example, in general, if I want to say that I want to withdraw some money from the ATM, I may be able to draw money from the ATM machine, but this is one scenario and one dynamic model. But in many cases I may not be able to withdraw money from the ATM because of a problem with my card or my balance and so on. So these cases will produce for me more dynamic models. So I'll take one dynamic model and along with the method specification I will be having the basis to start coding my method. So in this case, let's take example of the use case admit patient. In this use case, we have to build the method admit. And this method post condition says if there is no word object in the appropriate type, of course, of the appropriate type, whether male or female, with at least one free bit, then a null is returned. Means if you can find for me the right word, a female or a male word, with one empty bit, then the user will be, the patient will be admitted, otherwise a null will be returned. Now, if I find the right place and the right word for the patient, then a patient will be linked to the word, and the patient will be linked to a team, and the patient will be linked to a consultant doctor. And I can now return that my patient already admitted, and I return the value of the word or the name of the word where that patient was admitted. As you noticed, we have two situations. A situation where we'll have the appropriate word for the patient, and that's one scenario. And the other scenario where we don't have appropriate word for the patient. So this is another scenario. So we need to be sure that the method will implement both scenarios. In this diagram, we see an object diagram of the situation before admitting the patient, and after admitting the patient, you find that patient 8 is now linked to ward 3 and also linked to team 2 with the head of that team, consultant Dr. 2. So this is the scenario, and the dynamic model represents that the system has, so the patient has been admitted to the ward. But of course, we may not ignore, and we need not to ignore that in other scenarios we may not find the right word for the patient, and we may return null and apologize for the patient because we don't have the empty bit in the right word for him or her. Here is the sequence diagram that shows us the steps and walkthrough in form of sequence diagram of what should happen in this particular scenario. This is a general design that can be applied in this use case all the time. Now we go to the details of implementation, and as you remember the design, we take the information from the patient and try create an object of that patient that will represent the patient in our system. Then we start creating the links between the patient, the board, the team, and the consultant doctor, and at the end we return the word object to confirm that this user has been admitted to that particular word. So in this slide we continue with the details of the implementation and showing the specification of the admit method. Of course, one important thing is that we need to know that the order in which methods are implemented is significant, because some methods are using other methods, and the smaller methods, I may call them, used by bigger methods may need to be implemented first, so the bigger methods or the master methods can use them in the future. So it's very important to know that the sequence or the order of building the methods is very important. More of how methods are built, coding for the admit patient, the full code of the admit patient is given in this slide. You can refer to it and compare it with the specification covered in the previous slides and previous chapters or units of the code. Now we progress with building more of our methods, but we need to remember that each time you build a method, we need to follow the test-driven approach by writing tests for this method and then writing the code of this method and testing the code against the test cases built earlier. So for each test case, you should specify a test case for each specified aspect of the behavior of the method. You should specify a test case for each different class of object involved that may be treated differently by the method. You should specify a test case for any different state of objects involved that may be treated differently by the method, and you must specify test cases around each boundary used by that method. So now, as example of testing a method, we will take a method from the hospital system, get patient and wards. And this method is a method of class team. So in team class, we have the method get patients and wards. That doesn't take any parameter. We want to demonstrate how we are testing methods based on this particular method. So now we study the method and see that the post condition for this method get patient and wards is to return a map of pairs of patients and ward objects. So if you want to know the patients and the wards where the patients are for some particular team, then you need to call the method get patient and wards upon the object of type team. For this use case, there's only one specified behavior, which is returning the map of objects described in the post condition. For this single specified behavior of returning a map of objects, there are particular states of the system which the method could be considered likely to handle differently. So that's the point. If the method looks that it needs to handle things differently, then I have to build a test case for this, these different handling of the method duties. What are these different methods for different ways of handling things in the method get patient and wards? The first case is the case where the team cares for several patients. Now these patients are in the same ward as each other. So this situation, the team is cared for patients. All the patients cared by this team or cares for by this team are in the same ward. On the other hand, you may consider a different situation where the team cares for several patients, but no two of whom are in the same ward. It means they are in different wards, not even two of them in ward, every single patient in a different ward. Now, in this, taking about the boundaries to consider in case where team objects involve linked to no patients. So you find a team and you find that that team doesn't care for any patient in the system. So the boundary will test the cases we have when we have empty team and when we have a team caring for one patient, or possibly also a team caring for several patients. Now let's look at the test cases, and this is very important to handle and to master. So now on the format of laying out your test cases for the previously described situation for testing get patient and wards method from class team. So the class team, and this is our first test 1. What are we testing? We are testing for an empty team, and this is a boundary testing. We give the name of the method get patient and wards. We give the receiver and message, how the message will look like, we will use the team1 object, and the call will be team1.getPatientAndWords. In the testing, we also need to give the fixture and input. In this case, we will use the team1 as object of team, and we will use we will consider the situation where the patient's collection is empty, and we expect that an empty instance of map will be returned. If the patient's collection is empty in the team object, then the returned map should be empty, otherwise there will be a problem with our testing and there is a bug to be fixed. This is one test, and this is about the boundary testing. Now we will consider a different situation and different test case. In this test case, test 2, we test for a team caring for one patient. Again, the method is the same method, getPatientAndWords. Receiver and message will be team1.getPatientAndWords. What's the fixture? Now we will change the fixture, because in the previous fixture we have no patients to take care of, but in this case we have one patient only. So a team object team1 with patients containing patient1. So now we have team1 and patient1. Of course, that patient need to be placed in a ward. So we have a ward 1 of object word 1 of type word with patients 1 containing in that particular patient. So a patient object patient1 with team object team1 and word object word 1. Now when we call the method getPatientAndWords, we expect that a map object of PatientAndWords will be returned, and that map object will include and contain patient1 and word1, because that's what we have decided in the fixture. We decided that we have team1 taking care of patient1 who is placed in ward1, and that's what we expect from this testing case. We go further with more test cases, and in this case we are considering whether the team is taking care of patients in the same ward or in different wards. So test 3 will test for a team caring for several patients, some of whom are in the same ward as each other. So some of whom, so you find more than one patient of the same in the same ward cared for by the same team. The method again is getPatientAndWords. The receiver and message is team1.getPatientAndWords. Fixture, we need a team1 with many patients this time. In this time we have patient 1, 2, and 3. And we have word to place those patients in. So you have word 1 containing patient 1 and 2, and we have word 2 containing patient 3. So our patients now are distributed over 2 different words. So the detail says a patient object patient 1 with team 1 and word 1. Patient object team 2 patient 2 with team 1 and word 1. Patient object patient 3 with team 1 and word 2 this time. So now what we expect from the method getPatientAndWords, we expect it to return for us that patient 1 is in word 1, patient 2 is in word 1, and patient 3 is in word 2. And all these patients are under the care of team 1. If we get this result, then we know that our testing is giving us the correct result, no bugs in our implementation of the method. If we get different thing, then we know that this method is not implemented correctly and we need to fix the bug in that method. Last but not least, the test 4, which tests for a team caring for several patients, no two of whom are in the same ward. Means my patients as a team 1 is placed in different wards. Again, the method is the same, get patients and wards, receiver and message, team 1 dot get patient and wards. Now we look at the fixtures. We need a team 1 with many patients, 1, 2, and 3, and with 2 or 3 different wards, because we want every patient to be in a different ward. So we have 3 patients and 3 wards, patient 1, 2, 3, and wards 1, 2, 3, and all of those patients are under the same team. So we say that patient object patient 1 with team 1 but is in ward 1, patient object patient 2 with team 1 but in ward 2, patient object patient 3 with team 1 but in ward 3. We expect a result that patient 1 is in ward 1, patient 2 is in ward 2, patient 3 is in ward 3. If we don't get this result, then we know that our implementation is not correct. We have errors to fix and bugs to fix. Otherwise, if we get the expected results as in our test case, then we know that our method is giving us the right result. If we get all the test cases correct, then we can be sure that for a high level of confidence that our method is implemented as specified and in the correct way. There are many exercises in the block that will help you doing more testing for more methods to build your skills of how to create a test case and how to check your methods against these test cases. This is the end of Unit 10. Thank you very much. Wassalamu alaikum wa rahmatullah wa barakatuh.